Continuing with armature reaction of the armature current in an alternator. We are seen in the last class there is a effect of the armature flux on the main flux. They have got a different effect because of different types of load. In the resistive load, we have seen that there is a cross magnetizing effect. Then what is the effect if we are connecting a lagging load or a leading load? That we'll see. That is, once again, that is the modification of the flux, the air gap is because of the armature flux. The armature flux is depending upon two main factors, that is, one is the magnitude of the current which is flowing in the armature conductor, and the other factor is that the nature of the load. That is seen in the last session, that is, at this particular instant of time, the induced voltage is maximum, that is along the pole axis there is a maximum induced voltage, and the current is also is in phase with that one. Therefore coil should be placed in the polar axis when they are in phase current, means both current and voltage they are in phase. In that case there is a strengthening of the flux in one pole tip and weakening of the other pole. It is the similar in the S and N pole. Then if you are drawing a vector diagram for the flux, if you are taking a reference and it is a main flux, we know that the phase displacement with the generated voltage in the flux is, the generated voltage is lagging the flux by an angle of 90 degree. Therefore the induced voltage E is lagging phi m by an angle of 90 degree. It is a resistive load, therefore the current is in phase with E. Therefore when there is IA start flowing in the armature conductor, it is producing its own magnetic flux, that is phi A. That is also in phase because phi is because of IA. IA is in phase with E because it is a resistive load. Then the total flux is, it is a vector sum of phi m and phi A. Therefore what I am getting is there is a distortion of the flux, there is a change of the direction of the main flux, means it is a resultant flux. Therefore in this case what we are observing here is there is a cross magnetizing effect. If you are looking into the waveform, the phi m is leading phi by an angle of 90 degree. Therefore I am starting here, which is leading phi by 90 degree. Phi I am starting from this point, that is phi A. You can see here phi and phi m, the phase displacement is phi is 90 degree ahead of phi. This is how we have to draw the vector diagram. And if you are looking into the leading and trailing pole tip, in that case in the leading pole tip you have got the crowding of the flux or strengthening of the flux. In trailing pole tip you have got a weakening of the main flux. Then if you are connecting pure lagging load, means zero power factor, means we are connecting inductive load. In the inductance we know that the current I lags of voltage E by 90 degree. Current lags voltage by 90 degree. We know that in the case of the generated voltage, we know that the voltage is maximum at this point, that is voltage E is maximum. Then here we are taking a lagging 90, that is it is a pure inductive load. The current has to lag E by an angle of 90 degree. Therefore here the current means you have to place your coil at this point. You have to place this coil at this point. Means the current which is flowing here, which is lags E by an angle of 90 degree here. Therefore you have to shift this. If you are looking into this particular figure, it is meant for the unity power factor because the voltage and the current they are in phase. E and I is in phase. Therefore both are at this particular pole axis. But in the case of lagging load, this particular coil should be shifted by an angle of 90 degree here. because the current I lags E by an angle of 90 degree. Same thing I am showing here. With that example, just I am redrawing the figure. Just you can observe here. Here, you know that the voltage is maximum here. The voltage is maximum here. Means the current is maximum here because it is lagging the voltage by an angle of 90 degree because you are connecting inductive load, pure inductive load. Therefore, the current I should lag the voltage by 90 degree. Therefore, this coil which is in the unity power factor should be shifted to the right direction, right by an angle of 90 degree. That is, here it is a phase displacement of 90 degree. Here it is 90 degree. What I mean is, here that is the phase displacement, here it should be 90 degree. That is what I mean is, this degree is 90 degree because the current I lags E by 90 degree. Because this is the reference. This is the reference. With respect to I is lagging by an angle of 90 degree. This is how we have to interpret, and you have to shift the coil 90 degree in the right of the original position. That is for unity power factor whatever considered. Okay. Now we are shifted this particular coil by an angle of 90 degree in the right of the original position. Now once again, if you look into the distribution of the flux, one is the flux produced by the N pole and S pole. That is, under N pole the current is the emanating from the N pole, and whereas it is under S pole it is receiving the lines of forces. Therefore you can see here it is upward here, this is downward. Just you can apply the thumb rule once again here, and this is the direction of the flux produced by the main flux. This is the flux produced by the main flux. Then when the current start flowing, because now we are pure inductive load we are connecting, because it is lagging E by an angle of 90 degree here. It is lagging E by an angle of 90 degree. Therefore, if the current start flowing, then it is producing its own magnetic flux. Just you have to concentrate here, that is the current which is flowing in the conductor, they are producing the flux in a such a direction that here, if you can observe here, the flux is produced by the armature flux is in upward direction, whereas the flux produced by the main pole or main flux is acting downwards, means both are acting opposite to each other. You look into other side of the coil. Here the flux is acting downwards here. It is acting downwards because it is anti-clockwise lines of flux is producing. It is acting downwards, whereas the flux produced by the main flux is acting upwards. Therefore, once again here they are opposing each other. You look into the other pole, here also you can see here the main flux is acting downwards, whereas the armature flux is acting upwards. Once again there is both fluxes are acting opposite to each other. The other side of the flux you can see here. You can see here the main flux is acting upwards, armature flux is acting downwards. Once again here it is opposite. Totally in this case, that is the armature flux and the main flux, they are acting opposite to each other. Therefore, effect in this particular case is demagnetizing effect. If you look into the effect in the case of unity power factor, there is a opposite here, means there is a weakening of the flux. Here they are acting both upwards, therefore there is a strengthening. Here we are getting a cross magnetizing effect when the load is resistive. However, in the case of the pure inductive load, both are acting in the opposite to each other, so that there is a demagnetizing effect in this case. Therefore, if you are looking to the vector diagram, once again I am taking this as a reference. Once again I will start drawing the main flux, that is a phi m. Then the generated voltage is lagging phi m by an angle of 90 degree. Now current lags the voltage by 90 degree because it is a pure inductive load I am connecting, zero power factor lagging load I am connecting. Therefore, the current I is lagging E by an angle of 90 degree. This current IA producing armature flux phi A here, because the phi is produced by IA, therefore they are both in same phase. Now look into the fluxes. Yeah, that is the main flux is acting upwards, whereas the armature flux is acting downwards. They are opposite to each other. Then how to get the resultant? You have to deduct phi in main flux phi. So that what I am getting is this value is phi r. This value what I am getting is phi r. Phi r is, it is the difference between phi m and phi. Then what we are observing here, there is a reduction of the main flux. That is why it is called as demagnetizing effect. Because of the reduction in the main flux, the generated voltage ultimately it is reduced. Okay, this is how we have to interpret. If you are drawing the vector diagram, phi m I am taking as a, that is the main flux is I am taking as a reference here, and armature flux is acting exactly opposite to phi m. Therefore, I am drawing here. That is 180 phase shift. Therefore, phi m and phi a they are acting opposite to each other. If you are superimposing these two waveforms, what I am getting is this phi m. This is the resultant flux phi r what I am getting. Then you look into the effect of leading power factor. Leading means the current leads the voltage by an angle of 90 degree. In that case, from the original position of the coil, you have to shift your coil to your left side with 90 degree, because you are connecting here pure capacitive load. Pure capacitive load. Therefore, the current I leads the voltage by an angle of 90 degree. Therefore, we can look into here, the voltage is maximum. Therefore, your coil should be at this particular position, because the voltage is here is a maximum. Therefore, current has to be leading the voltage by an angle of 90 degree. Therefore, your coil position should be at these 2 points. Can observe here. See here. I am shifting. This is the original position for a unity power factor. Unity power factor. Both current and voltage are in phase. Now to make current to be lead, then you have to shift this to 90 degree in the left side. Therefore, it becomes leading. That is, the current is leading the voltage by an angle of 90 degree. Now, once again, you can observe the flux produced by the main flux and the armature flux. Once again, the flux is emanating from the N pole, whereas towards the S pole, that is the direction, that is, it is a set of the flux produced by the armature field windings here. Now, once the current starts flowing in the armature conductors, they are producing their own flux. Here, once again, it is anti-clockwise direction. Here, it is a clockwise direction. Okay, now we can interpret by looking into the direction of the flux produced by the armature flux and the main flux. We can look into here. That is, armature flux is acting upwards. The main flux is also acting upwards. Means both are acting in the same direction. At this end, you can look into here. The flux is acting downwards. That is, the main flux is acting downwards. The armature flux is also acting downwards. At this point, you can look into here also. It is flux is acting upward. Here is also acting upward. They are additive in nature. Here also, armature flux is acting downwards, whereas the flux produced by the main field is also acting downwards. Both are acting downwards. Therefore, all are additive. Means in the case of the pure capacitive load, then the armature flux is aiding to the main flux. In the case of the leading power factor, the armature flux is aiding to the main flux, therefore the total strength of the magnetic field is increasing. Therefore, effect is strengthening of the magnetic flux. And in the case of lagging, it is a weakening of the magnetic flux. But in the case of the resistive load, it is the cross magnetizing effect. Then if you are look into the once again the vector diagram carefully, the reference. Once again I am taking phi m as the main flux, generated voltage lagging phi m by an angle of 90 degree. Now I am considering pure capacitive load, current has to lead E by an angle of 90 degree. Therefore I am getting Ia here. When Ia starts flowing, it is producing its own magnetic flux along Ia only. Therefore it is phi. Now you look into the main flux and the armature flux, they are acting in the same direction, thereby the total flux is increasing. That is, it is a total F1. Means you have to add phi r to phi a to phi m, so that you are getting the total flux, that is the resultant flux. That is the resultant flux phi r, which is greater than phi m, because the armature flux is adding to the main flux. Okay, if you are drawing here, means both you can look into here. Phi m and phi a, they are acting in the same direction. They are both are sinusoidal waveform. They are in phase. Therefore, I am drawing one is phi m. I am drawing here. In phase with phi m, I am drawing phi a. Then the resultant flux is the vector sum of these two. Therefore, what I am getting is it is a total flux. That is a total of phi. It is quite evident from the waveform, as well as it is quite evident from the vector diagram also. Means in toto, that is in the case of the synchronous generator, the effect of the armature reaction is for resistive load, it is a cross magnetizing effect. For lagging load, it is a demagnetizing effect, whereas for a capacitive load, it is the strengthening the main field. It is aiding to the main field, strengthening of the magnetic field. Okay. With this background, in the next session, we will draw the equivalent circuit diagram of the alternator.